All right, so a little while back I had told you that I was beginning construction of a QRP Labs QCX Plus 20 meter QRP transceiver, and that work is done. It's finished. I will post some pictures of this, probably make a separate video that shows you kind of how the construction went. I've got pictures taken from almost every single day that I worked on it. So there'll be a separate video on how I got the thing built. It's not going to go into painful detail because, quite frankly, I'm not an expert. And as I stated in the first video, this was not beginner soldering required to assemble this thing. It takes a steady hand and it takes a little bit of practice to get this done. But that's another conversation. The part that I'm excited about here tonight is being able to test it on my own bench. Now, when I did finish building it, I did take it to a friend's house who had the right equipment to run some basic tests on it, and everything came out well. It's transmitting probably right around 4 watts on 13.8 volts, which is what the designer will tell you that it will put out with a 13.8 volt power supply. In order to get the full 5 watts that the designer intends, you kind of need to get up around 15 or 16 volts. Well, that's not a voltage that most people have equipment to deal with when they're out in the field or even at even in their shack. So I've restricted my experiments to 13.8 volts. So I've got the power supply configured already to 13.8 volts with a maximum current of 1.5 amps. I already know from experience that this thing draws near an amp on transmit, so I've got it set to not provide more than 1.5. And it's tapped out at 13.8 volts anyway, so we're not going to have any problems with that. I've taken a set of leads built for that power supply and converted them into a power pole, Anderson power pole connection, which then connects to a little power cable that runs directly into the radio. So let me make sure and stay in frame here as I talk to you. And then there's the radio itself. Now the radio has a BNC antenna port on it, so I've got a jumper cable here, a pretty thin one because we're dealing with QRP power. That is BNC on one end and UHF on the other end, and the UHF end goes into the Bird 43 through line watt meter, which has the appropriate slug in it. And if you don't know what I'm talking about, get out there on YouTube and find some videos that talk about through line watt meters by Bird. But in essence, what I'm saying here is that the slug that gets inserted into this baby needs to be rated for the equipment you're going to test. This particular rig will only put out between 4 and 6 watts, maybe 7 on a good day. So a 25 watt HF slug is perfect for this. And when you look at the scale on here, let me try and do this so we don't get a bunch of glare from my overhead lamp. You can see 3 scales on it. One for 100 watt slugs, one for 50 watts, and then one for the 25. They do make slugs for full legal power, and when you use those, you have to do some math to figure out exactly what you're getting on this thing. But that's another topic that I don't think I'll ever run into because I'm not a full legal limit operator. And then coming out of the output on the Bird meter is just a simple RG8X jumper that goes to my 300 watt dummy load, which we talked about a little bit in a prior video. So now that we're here, let's go ahead and turn the power on the power supply on. All right, so now it's set to 13.8. It's providing 13.8 volts, but it's not really drawing any current right now because the radio is not turned on. So let's power the radio on. And hopefully we can see this. Now the radio defaults to 14.055 megahertz, the way I have it configured. That's kind of in the neighborhood where I operate. I have not configured a lot of the optional settings on this, so I don't really have anything to show you there. But let's go back to the power supply and show you how much power it's pulling just in receive mode. And that's about 1/10 of an amp, a little more than 1/10 of an amp. Okay. All right. Now I've got my little CW Morse 3D printed keyer here plugged into it. So I'm going to key up the radio. It's in straight key mode, which means that, you know, as I press this and hold it, you know, it's going to just emit one continuous signal. It's not going to break it up into dots or dashes or anything like that. So for the first test, let's go ahead and record how much power it consumes when I put it in transmit mode by engaging the keyer here. And there, you've got 3/4 of an amp. All right. So that's on transmit, 3/4 of an amp, running off the power supply. Okay. All right. Now let's look at our RF output here and see what we're getting. And it shows just a little over 5 watts. Now, you know, the tolerances on the bird meter at this particular scale at 1 to 25 watts is about 2.5 watts. So it's running a little over 5 watts, kind of on its way to 6 here. All right. So we can assume it's probably putting out 3.5 to 4 watts, which is what the designer intends at 13.8 volts. Okay, makes sense? All right, and again, all of this is flowing into this dummy load here, so I'm not bothering the rest of the world with my test here. So one more time, just to capture it again. So just a little over 5 watts, almost 6. That line between 5 and 10 theoretically is about 7.5 watts. Okay? All right, so what I'm going to do now, so I'm going to replace the power supply with my little Bioenno battery that I purchased, and also an inline watt meter that me and a friend of mine named Bill, WA0CBW, we did a video on quite some time ago that's proven kind of popular. So we'll be back in just a moment after getting that in line, and we'll run the same tests again. And we're back. So I've got the little Bioenno battery. So just so we know, that's this is a 12 volt 3 amp hour battery, and the model number is 1203AB, BLF-1203AB. If you're interested. Now I'm not here to plug Bioenno batteries. I'm just letting you know what I'm using, so you know the conditions of the test here. All right. So, and this is the PowerWorks inline watt meter and power analyzer that I'm using. And right now you can see that it's seeing 13.3 volts from the battery and 0 amps right now because we're not transmitting. All right. So just like last time, we'll go ahead and turn the radio on. All right. There you can see it's come back up to 14.055 megahertz. And here's our bird meter. So I'm going to show you a couple things here. We're going to go ahead and key it up. And I'm going to extend the tripod on this camera so I can hold this meter up so you can clearly see what's going on. All right. So let's go ahead and key the radio up using the Morse code keyer. Morse code paddle, actually. All right, so you can see it's drawing 13.15 volts. That's a little bit lower than the 13.8 that I would like the battery to supply, but it's in the neighborhood. And it's pulling 0.72 of an amp from the battery. And you can see some other values flashing in the bottom left hand. Let me unkey the radio for a moment. All right, so 0.7 of an amp, and pretty soon you're going to see a value flash by there. There it went. We'll watch for it again. That's going to have an AH after it, and that's amp hours. All right, so this battery is pulling 0.011 amp hours. Now that will matter to people who take a battery out in the field to operate their rigs, because you know, if you're keeping track of your consumption from a fully charged battery, then you know how much battery you have left, and with a little bit of math you can calculate how much operating time you have before your battery needs to be recharged. So that matters for people who take their radios out into the field. So let's do it one more time and make note of that voltage. So it's pulling not quite 13.1 on transmit. So So let's make a note of that. It was 13.8 using the power supply, but we're only getting 13.1 out of the battery. So that's interesting to me. I'm not concerned about it, but it is interesting to me. One more time for survival. All right, 0.72 amps, 13.07 volts, and amp hours is 0.02 at this point. Okay? All right. So that's that. Now let's come over, because we know we're getting less voltage now, right? So if we're getting less voltage from the battery or from the power source, then we're probably not going to put out as much power as we were getting from the power supply. All right, so let's take a look at that. All right, we're getting just at 5 watts, maybe just a hair over 5, so a little bit less. It is noticeable on the meter how much less we're getting, but it's not really significant. So I'm pleased, A, that the battery is supplying enough power to operate the radio, and B, that I have the ability to measure these things now. So I have measured a couple of different things here. I've measured how much power is going out and how much power is required from a power source to produce that RF output. All right. And again, I'm using a properly rated dummy load to terminate this RF into, so that I'm not testing outside of my environment here. The tests that I'm running are not escaping out into the atmosphere or into the ionosphere with any strength. Okay. So the next thing I want to do is hook this up to a spectrum analyzer, and let's look at the signal coming into this thing on a spectrum analyzer. Be right back. Okay, so we're ready to look at this on a spectrum analyzer, and the spectrum analyzer that I have is the reasonably new, excuse me, Tiny SA Ultra, which is kind of a little more of a grown-up version than the original Tiny SA, which had about a 2-inch screen. This one has a 4-inch screen and has a little more functionality built into it. I'm not going to go into that. Just know that this is a perfectly good, right now, spectrum analyzer for doing what I need it to do. Now, you know, as I've already said in this video, I'm not an expert on test equipment. So there are things that I see when I look at things like a nano VNA and a spectrum analyzer such as this, or my own oscilloscope. There are things that I see that I don't quite understand yet. I'm working on those things, but I just want to come clean with you and make sure you understand I'm not trying to pass myself off as somebody that I'm not. So as an example right now, you can see in here that even though I'm not transmitting, there's already a signal that's being captured at 14.056 megahertz. I don't know where that's coming from, but I do know that that amplitude is not what you're going to see here in a minute when I key this radio up. So again, we're going to use the CW Morse iambic paddle. The radio, however, is configured in straight key mode, so it's going to behave like a straight key. Let's get my frequency back on 0 here. All right, and then we'll key it up. Now, one of the things you're going to notice when I key this thing up is that the frequency that is recorded by the Tiny SA Ultra is going to be a little bit higher than the frequency that the radio is configured to transmit on. So that shows that the radio is not quite zeroed in on the frequency that's on the display, but it's really, really close. So let's key this thing up and take a look. I apologize for being able to see my hand on the reflection here. I don't really know what I can do about that right now, but hopefully it won't be too much of a distraction. So we'll key the radio here, and we see a signal on the same frequency that passive signal was received on, but the amplitude's a lot higher, and it is at 14.0566 right now, which is, you know, about a K higher, a K and a half higher than what the radio is set to. And that's perfectly fine. I have made contacts on this radio, and it works fine. But the important thing to note here is that the signal coming out of this thing is pretty clean. There's no real artifacts real close to the transmit frequency. We can see a bit of a harmonic down there below. I'd have to do a little math in my head to see what frequency that's popping out on, but it's not close enough or loud enough to be recorded as something that the FCC would not be happy with. And we're operating a pretty low power here anyway, about 3.5, 4 watts, right? So we're okay here. One thing about this spectrum analyzer I do want to point out, besides that it's perfectly good functioning spectrum analyzer for what we're doing, is I've got a 30 dB, I think it's a 10 watt attenuator going into it, which is necessary. If you transmit, 3.5, 4 watts directly into a spectrum analyzer without some attenuation, you're gonna destroy your spectrum analyzer. So make sure you're using proper attenuation when you plug your radios into these things, regardless of what spectrum analyzer you're using. This was a $120 model purchased from R&L Electronics, but they make spectrum analyzers, if you don't know, that look a lot like that oscilloscope that cost upwards of $1,000. So if you're going to invest in this kind of equipment, make sure you understand what it's going to take to safely operate them without subjecting the equipment to any unnecessary damage. So that's the spectrum analyzer view of how the QCX Plus is doing here tonight. And I just want to say again that I'm very, very pleased with how this turned out. I will make a video that shows how it was built day by day, talk a little bit about the construction that went into it, and I'll get that posted as soon as I can. But I wanted to right now show you that the radio is worth building. I have made contacts with it. I'll try and include a picture, if I can remember to, right here, that shows a map of some contacts I made while doing a Parks on the Air activation a week or so ago. That'll just show you that even at less than 5 watts, using Morse code, which is all the rig is capable, is the only mode that the rig will operate on. Just how well you can do, especially under the conditions we're experiencing right now, which is on the upward slope of a new solar cycle. So by all means, if you're interested in QRP and have some soldering skills, this rig is a good investment at less than $100. That's it for tonight, folks. Thanks for watching, and I hope we learned something together, and I will keep you in the loop on what else is going on around here. This is Kevin at radio station AD0IM 73.